evening. How we all doing? And yes, happy Friday. Not that I get to have a Friday. I work every day. It's true, Caesar, I do. So I believe we are doing a competition giveaway, first thing, before we get cracking on the stream. Claire, can you please confirm that you are in situ and ready? Oh, and I remember to turn the fish tank off, because on the last stream it was really loud because I forgot to turn off the pump. So hopefully we don't have the sound of someone peeing constantly. Oh, okay, we're not doing the competition tonight. Okay, sorry, my bad. Well, in that case, we will crack on. So let's have a look at what I've been doing. And as usual, I haven't got a clue, so I need to look at my notes. Dooby-dooby-doo. Yes, so I fixed a whole load of bugs, so hopefully that has smoothed off some rough edges. I guess the headline thing over the past couple of days is that we now have object avoidance for the ship on the autopilot, so it will now make a reasonable effort to steer around things. So if we get rid of my ugly mug, and then we can have a look. So the issue on the last stream when I was trying it and it wouldn't work is because we have some back to front coordinate issues going on. The forward direction in SketchUp is different from the forward direction in Unreal. So when I exported the ship model, it's facing the opposite direction to the galaxy, essentially. So its forward vector is the reverse of the galaxy's forward vector. So when we were working out, is the ship facing something, those values needed inverting, basically. I will make sure that for every other ship moving forwards, I'll fix that so that it's facing the right way. But that was just a very early gotcha from a few years ago when we first started building it. And it's going to change again because Unreal are going to completely overhaul their coordinate system. So it's like right hand up or something. Like I can't remember exactly what they're moving to, but in the next couple of Unreal Engine versions, they're moving to the kind of more unified 3D modeling coordinate directions, which is Y up rather than Z up. So when they do that, it means that our galaxy and all of our ships will have a different up direction to the engine. So we're going to have to probably make some changes there to flip everything around so it all lines up again. Yeah, right, so let's just give this one a quick whirl. Hey, Don. Oh yeah, my ship is very black because these seem to be loading as the defaults when we don't have a save game. I need to look into that, make sure that at least if I'm testing it in the editor and we haven't created a save game, I need to make sure it loads the proper defaults. You shouldn't have that issue in game once it's packaged, because obviously you can't start a new game now without setting up some save file entries. So that should only affect me. Actually, it should immediately fix when I click that. Yeah. Right, so if we select Alpha Centauri, because I happen to know that it's over there around the rim of Earth. So our nav target should be, yeah, down there. So you can see the nav target is through Earth. So when we engage the autopilot, what it's going to do is actually two different things. One, it's going to angle the ship to the orbital plane of the star system. So you see it rolled as ever so slightly to the left. So here, obviously the sun, you've got all the other planets that all say unknown because it's not loading the save file. But it calculates the up vector for the orbital plane and always tries to align the ship to that orbital plane if the autopilot is engaged. And then the other thing it does, if we look forward there, that distance is about 10% of the radius of the planet. So whatever planet we're avoiding, we'll always try and miss it by about 10%. Now, we've only just implemented this, so there's some testing to be done. If that's proving to skirt the planet a little bit too closely, then we can widen that percentage very easily. But by default, it will try and skirt the planet by 10%. So even though our target is down there, the autopilot, when it picks its vector for missing an object, the vector it picks is always on the orbital plane of the star system, which is why we're nose up to the target, because the target's below the orbital plane. Once we get beyond the planet and it's no longer in our way, then the nose will tip down to the actual target location. So if I engage the FTL now, you'll see that we'll steer around it a bit and then dip down towards the target, thus missing the planet. From what I am told, there are still a couple of issues where if the target location is very, very perpendicular to where you are, it can still plow through the planet sometimes. So I need to refine that and make sure it absolutely never will. And also, if you're flying manually, you can of course just plow the ship into the planet yourself. So I need to make sure that if you get within a keep out zone, which will make 10% of the planet radius, as an additional 10% on top of the planet radius, then it will do an emergency shutdown and purge the FTL coils and cause a bit of damage to boot. So whether you're doing that or the the autopilot is accidentally doing that, it should drop you out of FTL rather than going through the planet. The other thing I did is, you may have noticed we sped up more quickly than usual. I have slightly increased the ramp up speed for the FTL coils, so you don't kind of slowly start moving and then speed up. The speed up is a bit quicker, just to make it a bit more smooth. And similarly, when we're approaching targets, if we just pick a random planet, you'll do. What happens now is the throttle, or rather the FTL power, is clamped at 10%, so it will never throttle down less than 10%. So you won't have a kind of a slow, painful crawl to the point where the ship stops. And also you'll notice it's stopping next to the planet rather than aiming directly at it. So if there was to be some kind of FTL failure, you would miss the planet. But yeah, as we come to our arrival point, the field power should stick at 10%, which is 75 kilometers per second, if I recall. Yep. So you maintain 75 kilometers per second on your final approach, and then it will drop you out of FTL. Now, what we need to test, and something that I'm actually going to look at tonight, is how that works with small objects that are around a planet or whatever, something like a space station sized, because we want the ship to exit the FTL like really no further than a kilometre away. We don't need it to exit right on top of the object, but it's certainly not so far away that it's going to take you ages to crawl up to it. So we need to see if we can get the FTL to disengage promptly. And I'm worried that approaching at 75 kilometers per second might be a bit too fast of an approach for it to nail that target, because you're still looking at well, actually let's have a look and see exactly what that would be. Because we've got my handy spreadsheet. So if our throttle is on 10%, yes, so we're moving 3 kilometers per tick, and it's 30 ticks per second. So that's at 90. So 9. Sorry, no more than that. 90. Yeah. So 90 kilometers per tick per second. I'll get there in the end. So the chances of missing that object are huge. So we might need to slow this down so that the ship is actually able to nail its exit point. What we don't want to do is like artificially place the ship at its exit point. I mean, ultimately we might have to. So if it's not able to shut down the engine within that 1 kilometer range because of like the skips that we're doing, it's basically, it's not moving the ship through space linearly. It's going kind of so every tick right now. So at 10% throttle, it's moving the ship 3 kilometers at a time, 30 times per second. So it's not moving smoothly through space. But obviously to achieve FTL speeds, that's how we have to do it. So it might have to be the case that once we are within, I guess, a couple of ticks range of the target, we freeze the ship at our point of departure, and then just shut down the FTL drive. From the player's perspective, you shouldn't notice much of a difference because you're moving at 75 kilometers per second anyway. So something the size of a space station would be gone in the blink of an eye. So yeah, we'll have to see if we can nail that exit point, either by the autopilot being quick enough to do it itself, or by freezing the ship in place as we turn off the drive. But that's one of our fun little challenges that we can do. I think that's how Elite does it. I think when you exit frameshift drive, you often get that kind of delay before the ship kind of suddenly appears in its destination, and I do wonder whether it's doing a similar thing. It's freezing the ship in place and then handing you control at the desired distance. The ship already does use a distance curve, so the autopilot basically throttles down from half a light year away. So basically it's 100% throttle all the way up until you enter the cube that contains the star system, and once you're in that cube, it throttles down from 100% down to 0 at the exit point. So in many ways, it's a bit like a hover slam, like the Falcon 9s do. They do their burn as they're coming down to land, and then they shut the engine off right before they start going back up again. So like it's like timed to perfection that the engine turns off just as it touches the ground. Any second later, it would start going back up because their thrust to weight ratio is so high that it can't hover. But we're doing something like that where we're throttling down and down and down, and we don't hit minimum throttle until you're right on top of the exit point. So yeah, there is a smooth curve as you come into the system. Yeah, the way the FTL works is it takes the sublight speed of the ship, and that's basically dependent on whatever the thrust capability is of your engines, your sublight engines. And then when the FTL drive is on, it multiplies your actual speed with some kind of multiplier. It's a crazily high number, but basically it's the sublight engines that are determining the speed of the FTL. Generally speaking, you would full throttle the engines to go as fast as you can, then engage the FTL, and then ramp up the FTL power. And the stronger the FTL field, the more of a multiplier it's putting on your base speed. And that's multiplied in the direction that the field is facing. So if you were to turn your ship 90 degrees, so it's perpendicular to the field, then the FTL would be having zero effect on the vessel's movement. Most of that is not actually modeled yet, but that's basically how it's going to work. It's a multiplier. So when you exit FTL, your ship will be moving at sublight the same speed that it was before you turn the FTL engine on. So you will be moving probably at maximum thruster speed when you exit the FTL. So on that note, when we were doing the Caravella, no, that's the wrong map. We were experimenting with a system where we could spawn in content based on a moving grid, the same way that we generate the galaxy, basically, but on a really, really small scale. And I wanted to see whether or not we can experiment with that to see if we can just spawn in some cubes or something for the FTL to exit in front of. I can't remember, because this was a while ago when we did this. Can't remember whether I actually added it as part of the world or not. Could have been that, actually. I think this is already potato aware. Yeah, this is already a potato. So ultimately, we want to be able to spawn these potatoes in a dynamic way as you're moving through the grid that is the star system. And I can't remember, again, because it was many, many, many months ago, what we were actually using to do the spawn. Yeah, because that's just spawning them in a cube. So since we last looked at the Caravella, and while I remember, this is something we had to sort out because obviously we've got a whole new loading sequence now, so we need to make sure that it properly complies with all of that. So it's not getting as far as spawning any of that, which means that must not be firing. Yeah, it's all messed up. I'll come back to that. Basically, the loading sequence has been changed quite a lot, so it's relying on a lot of these broadcast messages to go through the startup sequence, and various different aspects of the ship's hardware broadcast all of these different signals, essentially saying, right, I'm done, on to the next bit. So I need to go through the startup chain and make sure that everything for the Caravella is actually broadcasting properly, starting with the initialization, which should be coming from our game state, but it's strange that it's not. But no matter. Let's get rid of all this framework stuff. Yeah, so I must have taken our spawning grid off of that. Not to worry, I shall dig it out from wherever we squirreled it away. Oh, that was it. Right, let's stick this on our test map. But no, I will go back and fix the Caravella's map file so that everything's loading properly. Because now that we can select it from the main menu, it would be nice to polish that up a little bit and get it usable. Right, I should add that next to our little array of stuff. All our little server boxes in the server room. Yeah, well, when we implement the NPC captain, will simply just start doing the job, basically, of exploring everything. So if you put an NPC captain in charge, then they'll just go ahead and explore every star system, specifically looking for Earth-like worlds and tech signatures. To be honest, we could look at that if we don't get any joy with this. Let me just go through this a minute and work out what I did when I did it. Improve a few bits of this. Generally speaking, multiplication is quicker than division on a CPU, so I always try and use a multiplication rather than division if I can. So we don't need that. so we should see some red cubes if I recall. No, Anasi. This is very specifically adding something which is completely on its own and not connected to anything else. So this sub-like object gen is basically just a little box that you can just delete from the level, and then it won't work anymore. And it does nothing connects to it, and it doesn't connect to anything else. Yeah, probably. Yeah, you put this in and nothing else works. Yes, that's been replaced now with our gameplay messages. Okay. Hurrah. So these cubes are basically where content gets spawned. Can't believe they're also casting shadows on the planet. So let's make sure they're lining up, because they don't look lined up. So as we fly forwards, it should be constantly regenerating this grid of cubes around us as we go. And that should be a uniform grid, not the messed up grid that we're seeing. So what we need to decide from a design perspective is how big do we want these cubes to be, and this is really dependent on how fast the ship's moving. So obviously if we're nipping along at a hell of a rate, then content is going to be spawning so quickly that that you'll never see it in time. So the cubes need to scale with ship speed. And only actually start generating when the ship slows down as well. So if you're just winging through a system, it won't even engage the content spawning. So basically what we're doing with this is exactly the same as what we do with the Galaxy Jet, where we're picking a distance for offsetting our cube sizes. At the moment we're using 1,000. That's 1,000 kilometers. But the cubes themselves don't seem to be the right size. If we make them smaller. Yeah, basically. So the ship entering one of the cubes is essentially what's going to spawn the content. I just need to make sure that the grid is being spawned uniformly, which doesn't appear to be. So yeah, we should be looking at a uniform grid of cubes which are perfectly aligned. So there should be 27 of them in a 3x3x3 grid. I'm wondering whether it's actually offsetting them yeah, by the world orientation. Let's have a look from the helm a minute. Yeah, so rotationally they're staying well, kind of aligned. Yeah, so that is the grid. Okay, now we need to make them not stuck to the ship, basically. Hey, Danger Mouse. Good to see you. Okay, so if we keep it to the 1,000 kilometers then, and we will put our cube size back to the right size. So the reason it looks messed up is because we're spawning them or rather are attaching them to this actor, which you don't necessarily want to do. We want to keep them world aligned, or rather galaxy aligned. So we would need basically the same as we're doing for the galaxy. Yeah, because we don't do this for the Galaxy Gen itself. We've never done like a visualization cube for it, which would be handy to have, to be honest. So it would work fine if the ship is already on the galactic plane. So what we'll do is we need to update this so that each cube is kind of locked in space, which means it needs a relative offset based on the position of the ship. So we're probably better off spawning one of these proxy objects. So these proxy objects are what you see visually in space for the thing that exists physically, that is the physical object in the world. So each thing that we spawn should in turn spawn a proxy object. Now, right now, they are just set to potatoes, but we need to start making maybe a child of that. Let's call that sector cube. So there's our cube. So we want this cube to continually update its orientation based on what the ship is doing. So it should be doing that on tick. I need to store this value better. So the way we will be drawing objects is we will be basically picking a location underneath the static ship interior, and that's where we'll be spawning the interiors of space stations, alien derelicts, shuttles, and anything else that you can physically walk around in, including planetary surfaces. So we need to spawn them really, really far down below the ship interior, so they're out of view, essentially underneath you. And then what we do is we teleport the player between those different layers, depending on which vessel they're on. So the proxy thing you see out of the window obviously needs its location relative to the interior that you're in, and that's what this offset is supposed to do. I'll leave it just stuck to the Magellan for now, although actually that's the Caravella one, isn't it? So Magellan is at 0. Actually, no, the Magellan was that one, because the middle of the Magellan geometrically is not where the bridge is. Yeah, I was considering making some shorts. Obviously, the game is taking some time to make. It's taking longer than any of us want to make. But if we get loads and loads of people interested now, then all those interested people have to wait for the game to be finished. So they're going to get bored of waiting, and they'll get fed up of how long the game's taking. Whereas if you were to capture those same people further down the line, then that excitement is rewarded with an actual game. So we need to be careful to get a decent amount of interest to help the game tick over, but not so much interest that we get too many people too quickly and then everyone gets bored. It's a fine balancing act. I'll skip the visibility check on there for now. Yeah, exactly that. It's just not generating too much hype too quickly. Because people, quite understandably, they will get bored of waiting. I can think of a number of games that I was like super hyped about when they first announced it, and then after a few years I just completely forgot about it and never went back to it. I think Ashes of Creation is probably the best example. I mean, I first heard about and got excited about Ashes of Creation. It must have been at least 10 years ago, if not longer than that. And it just dragged on and on and on. And there'll be, you know, like the occasional newsletter here and there. And then that dragged all up to the point where I think they've now cancelled the game. So yeah, that was a bit of a nightmare. But fortunately, I forgot all about it. So it's all good. Hey, Jim. Yeah, we've definitely had our fair share of people say that the game is taking too long to make. And, you know, they're not wrong. It is taking a long time to make. But these things do take time. It's just, yeah, it's just one of those things. These kind of projects that are this in-depth just take time. There's just so much to do. Yeah, I'm terrible at ETAs. Yeah, as Claire always says, I'm doing this because I want to do this. And if it weren't for the community or Kickstarter or anything else, I'd still be doing it because it's something that I started as a hobby, and I will continue it as a hobby, regardless of anything else. Okay, so what we need to do then, we've got our actual physical object, which is our space object, and eventually all objects that we spawn, from enemy ships to rocks in space, are all going to be basically inheriting from this same class. And the importance of this class is that it sets up the object itself in space as something that can be tracked, and it spawns and manages a proxy of itself as well. So that separation between the physics simulation and what you see outside the window, which is all smoke and mirrors, this is kind of the nuts and bolts that manages all of that. Right now, it's a bit different in the game because it's all childed from a single anchor point. This is the upgraded version, which manages each object independently. And I need to convert all this to a base C++ class that everything can then just be a child of, to make sure that it is rapid and easy to replicate as well. So rather than adding a static mesh component, what we need to do is we need to spawn an actor from class and then handle that bit, or rather it should handle this bit on its own, but we shall see. Okay, so this should all be aligned to the galactic plane. And I'm wondering whether or not we actually align this to the system plane instead, so that the grid conforms to the up direction of the star system rather than the galaxy. But that might be an additional layer of complication that we don't necessarily want. But I'll think on that. It's easy enough to get the up vector from a rotation, and we have the rotation of the system stored. But it would mean calculating all these offsets based on an angular plane rather than a flat plane, which does make all the math more complicated. And I try and keep things simple wherever I can. Okay, so what we want to do then is we want to take our working sector midpoint and spawn those objects there. And then the object scale is going to be this. So don't need to worry about the mesh necessarily, because it's not something that we can collide. Normally, it would be something that the ship can actually collide with. So you'd need a mesh with collision to go there, because this is the physics actor that we're spawning. Yeah, then we just need to. What's that? Yeah, so let's promote that to an array. Oh, come on, computer, wake up. Hang on, we're suffering from the lags. There we go. Okay, and then make sure that we clear any existing actors before we spawn in some new ones. Okay. So that's that, which is that one. So I am going to need to give that a mesh. Actually, how big is that mesh? I'm assuming it's 1 meter. Yeah, it's a 1 meter cube. Makes it easier to calculate. Let's just see whether it actually spawns anything. It's nice and laggy. No, I don't think it's you, Delta. I think it's when Unreal maxes out the CPU, obviously the stream then struggles. Oh, that doesn't help. We're not actually collating the list of things to get rid of. So that should only run if our coordinates are changing. Yeah, so we'll get our local coordinates, checking our last local coordinates, and basically if they have changed, or rather if the cube has changed, then we will generate a new cube. I'll skip that bit for now. Ultimately, the point we want to get to with this is that once we've got a solid and established grid that we can fly around, then we can start the process of spawning objects within that grid. And then those objects obviously then have to be available on the sensors as well. Only the short range sensors though. This is going to be purely a short range thing. Yeah, I need all the tabs. They're my happy place. But it must think my sector's changing, otherwise it wouldn't be doing that. So the issue there is the cube is sticking to the orientation of the ship, which we don't want. We don't want it to do that. It needs to be stuck in place relative to space. I will get rid of some tabs though, because I keep clicking on the wrong one. Right. Oh, okay. Yeah, we don't want to do that. That's why it was flashing, because we're forcing it to do it over and over. So essentially, we just want to do that once. So we'll do it once at the start, and then from that point on, it will only do it when we move. So that should stop flickering now. Sort of an ASSI, sort of. So the things that will be spawning using this local object grid, this is going to be stuff which is small and only detectable at short range. So if it's something like a derelict ship, it's going to be emitting a very small amount of power, something that you're not detecting from medium range or long range. These are bits of content that you will only find if you spend time looking around planets and things. So the entire star system will be split into a grid, and then each one of those grids grid cubes will have its own seed, and then that seed determines what is spawned there. The chance of something spawning there is going to be driven by proximity to gravity wells. So a planet obviously has its hill radius, and that hill radius will greatly increase the chances of something spawning on the short range content spawning grid. Outside of that hill radius, there'll be a much smaller chance of anything spawning. And basically this is a way of adding a lot of clutter to a star system, to the point where it could literally just be a bit of scrap metal from a passing ship that was ejected a long time ago, just floating through space. And something that small, which could just ping up on the sensors if you're near it, means that we can literally fill a star system with trillions and trillions and trillions of objects that are small and only there if you happen to be near them. So there will be objects that could potentially spawn within a system that no one will ever find, because no one just happened to go to that exact point in space where those things are. So there could be an alien derelict around a planet, and unless you actually took the time to just explore around the planet a little bit, you'd never come across that derelict, because it's obviously such a small object in space. So this is kind of our way of greatly increasing content density without adding it to the overall data structure of a star system. So the star system data structure stays light and small because we're spawning this stuff procedurally, like in relation to where the ship is. Obviously it's seed driven, so it will always be there for every player, but it doesn't need to be pre-generated or pre-stored in the same way that the star system itself does. Yeah, exactly. I stole them all first, as they're all in this this content system. But yeah, before we can do that, we need the grid established and properly updating. So we should be spawning 6 of these sector cubes. So let's just make sure that we are. And we'll just see where we're spawning them. Sector cube spawned at, I'll give that location, so what do we get? Location. So we should see 27 of these, and only 27, because the ship isn't actually moving. Okay, so it did 2 generations, so we can probably skip the first one. I imagine it did that before the ship was properly positioned. Where are we? Which one was it? That one? No, that one. So if we get rid of that, and we'll rely purely on our ship state check, and I imagine that's probably set to, yeah, so our current sector is set to all the 9s, so it's definitely going to be different from the one that we calculate. And then we will basically flag that as false once the levels are loaded, which means it will go ahead and do that. So that should now be a one-time thing. Okay, there we go. So that's our 27 sector cubes. So that's numbers in kilometers, basically, which should match where the ship is. In fact, why don't we? We'll compare that. Do that with a vector, although I might actually make a macro for converting a vector in centimeters to a vector in kilometers, just to save having to do this each time. Make that linger longer so that I can read it. So the location of the cube needs to be approximately where the ship is, which it does seem to be. So we've got 7571, 7571, 3569, 356, 89, 1235, 12535, 12535. Yeah, so other than the Y being slightly different, those cubes are where the ship is, so that's good. Okay, so having spawned them in, so where the ship is and what the ship sees outside the window is where the conversion gets complicated, because the ship that you're looking at is all static in the world, and this exists at the real world origin, which means that physically these sector cubes that we're spawning physically are like 1 AU away from where we are here, and that's 1 AU in centimeters in very real world units. The actual ship simulation mesh is also that far away from the world origin, so you can't see either of those things from this static bridge. So what we need to do is make sure that the proxy objects that you can see are offset by that exact amount, so that they appear in space where they would be if you were on top of your actual ship location. So that's where these two things have to kind of work in concert with one another. So we should be setting the scale of this. Should be spawned in world coordinates. just for the avoiding of any confusion, let's just go ahead and set the scale there. And we shan't bother taking the scale from the base object. Normally, for a normal object, you'd want the scales to match. But the object we're spawning in this instance is literally just there as a visual indicator, so we don't need to really care about that. It's the proxy scale that we really care about. This is just existing in space to give us an anchor point that this can feed off of. So that's big. Okay, yeah, we can skip that as well. So yeah, so that's our proxy actor. Then we're setting the scale of that, and we can potentially skip doing the scale here and just handle that on the cube itself. What I'm going to do is, rather than making this a child class of proxy object, I think we'll just get rid, clear that reference from there. Yeah, we'll get back to that in a minute. Just to avoid any confusion, we need to make sure that the object is definitely the right size so that we can see it. What we don't want is to have it so that we are spawning it in the right place but we can't see it. So we need to know, is it the location that we're missing, or is it the object scale that's the problem? Yes, actually we won't. Can't remember why we're doing that. Oh, of course, because we're telling it where it needs to be. Right. Yes, so this needs a reference to that. So that means it is going to need a copy of that class unless we go through and change that. Yeah, I think we're going to have to ultimately. That's why it's important that we set up a base class for this, so that in future it doesn't matter what type of object we build off of this, it's always basically doing the same thing. So yeah, so we're broadcasting our object transform. I guess we don't need to do it that once if we're already doing it at 60 FPS. Yeah, so what this is doing, that's basically we are spawning in our physics objects essentially, which we're hiding. We will skip all of that because all we really care about is where it is in the world and that it's hidden, and that's just a cube anyway. And then we spawn our proxy object basically at the world origin, so that's going inside the ship's bridge by default. And then what we do is we set the transform based on the offset of where we are. So yeah, so we're telling the proxy where its proper sim object is in the world. So what the proxy object should be doing is reading that variable, comparing that to where the ship actually is, and it's positioning itself relatively to that object. Make sure that it is actually visible by default. So it's not hidden in game. Mesh is visible. It's not hidden in game. Yeah, so we'll make sure it's always visible just for testing purposes. Okay, and our mesh is huge. Okay. So we'll just, for now, just say proxy spawned. So there should be 27 of these, one for each of the physics objects. We start off our timer for moving the object around. It's not a ship, so we don't need any of that. And we don't need to worry about that either. So we're literally doing nothing but displaying a cube in space. Okay, so 27 objects, 27 cubes. So where are the cubes? That is the question. So the cubes should be, because of the offset, they should be right on top of the ship in real world units. So let's just see where that was actually spawned. So let's grab that just to make our life easier. Actually, let's let's delay for a second to give it a chance to actually position the object where it needs to be positioned, because we need to know that it's in the right place. Okay, yeah, so it looks like it's moving the object somewhere weird. Hey, Sempit. Do I have plans to develop events like solar flares, making bit flipping or electrical sensor faults and stuff like this? Yes, basically. So random failures aboard the ship, absolutely. Every component, every wire, cable, pipe, data circuit, all of it is going to degrade over time. So the longer the ship is flying, the more things are ticking down. Obviously the engineering crew will be doing maintenance and making sure that stuff doesn't break. But over time, things will need replacing. And things will fail, you 3D print a replacement, replace the object, and everything should be working again. In a nutshell, that's how that's going to be. But yes, we'll also have events in the galaxy which impact the ship. Some of them will be natural events, and some of them will also be slightly more sci-fi. We want, say, a nebula which affects the ship in some negative way. It might make FTL really bad in some way. It might start corroding your hull in some way. It might completely ruin your sensors. Yeah, there are lots of different things we can do to have a nebula in space affect the ship. So you never quite know whether one of them will in some way. But yeah, over time, everything we can think of, we can get into the game, essentially, because we just want to keep expanding the galaxy and the impact the galaxy has on the ship over time. Yeah, and of course the Janeway Nebula. Bear with me 2 secs. I need to go and close my door because it is increasingly getting freezing in here. That's better. It's got to that point where my hands are so cold that my fingers can't type anymore. You're getting old when your fingers freeze up. Don't know why that keeps going up over there. Right, let's have a look at these coordinates then and see what's going on. Yeah, so this is the offset in kilometers for the physical object in the world. So what this should be doing is doing an offset of where the ship is backwards, back to the middle of the world, basically. So those objects are out there, they're just out there in the wrong place. Which is interesting because we tested this with potatoes and the potatoes worked fine. Hey, Seeker. Interesting. So this make relative transform should basically take the transform of the actual object in the world, wherever that may be, and then offset that from where the ship is. So that should be the inverse of where the ship is, basically. Yeah, and then we're literally just setting the location of this object to be the inverse of that. Now, I don't think we were doing anything different on this one. No, basically the same thing. Let's make sure we're not sending that a different version of that. No, so it's literally just the location and rotation in the world. That's our proxy object. Oh, hang on a minute. Hang on a minute. It would help if it knew what object it was working with, wouldn't it? Still miles away, so we're going from plus that, so that should be minus the same amount, basically. An idea. If we just do one of them rather than all of these, so specifically we want the middle one, which is that one there. Oh, the one I just deleted, that one. So you are 13. Yeah, so the middle box is array element 13. So if we just only spawn the middle one, then we can do some debug on that to work out what's going on with it. So we shall just get 13 from there. We'll skip that. And then we'll pop that on the end. just so we're not killing the loop. Okay, so the one that we're dealing with should be the one immediately on top of the ship, because it's the one that we're in. So we're only spawning one of those, which means that we can do a little bit more aggressive debugging on this. So if we do that, and I think multiply that by -1. Because we know that the rotation is going to be 0, 0, 0 at all times on this particular one anyway. So really we just want it to rotate in the opposite way to whatever the ship is. And if we minus that location from that one, that should put it on top of us, I think. No. The other way around. So we want to just trying to get my head around the vector math here. So obviously this is minus 75,000 odd. So are we doing it the other way around? Because we want a value close to 0, essentially. Okay, no, so that's putting it directly on top of itself. But why would that put it on top of itself? Because the ship coordinates... Let's keep that as centimeters so that we're dealing with the same scale. Actually, while we're at it, let's put that underneath, just so we can compare them on top of each other. Ah. That should be longer. Right, okay. I think I see what the problem is here. Basically, the sector cube is, I think, being spawned using kilometers rather than centimeters. Whereas, of course, the ship's position is in centimeters. So this needs to match roughly. Obviously, the ship's not necessarily going to be in the center of that cube. So our formatting here so we're doing that by kilometers. I think this needs to be in centimeters. Okay, then we do our offsets, which at this point is in kilometers. So I think this is where it's failing, because we're dealing with 1000 centimeter cubes. So we need our length converter. I think it was 100,000 actually. So 1 kilometer, yeah, it's 100,000 centimeters. But we want 1,000 kilometers, which is 100 million centimeters. So we're dividing by that. I think we need to times it by 1,000. So each sector cube is 100 million centimeters along each axis. So the sector midpoint would be now in centimeters. So the offsets are also in centimeters, which means our sector ID, which is irrelevant for now because we're not using it for anything yet. So let's skip that for now, because the only thing we care about right now is that midpoint. So the transform location is now in centimeters and not kilometers, which means we can collapse this. No, just do that again. I don't think we actually needed to do that. So right, let's see whether those numbers now match. Interesting. Oh no, actually that's probably not far off. Although that said, yeah, so if the ship position is this, then why is that being truncated as well? I think the thing with the potatoes is they were local to the ship, so they weren't behaving in the same way that this is. So what we're doing with this is we're spawning that object properly in space, which I thought we were doing for the potatoes, but obviously not properly enough. Because the cubes were rotating like they were stuck to the ship when they shouldn't have done. I'm going to skip that as well. In fact, I'm going to plug that straight in there so that we're making sure that we're not messing with the numbers at all. So just so that we're clear. So we start doing our local movement, we wait a second, and then we report where the object was actually spawned. And we'll make that hang around for a minute as well. So this object should be very close to the world origin. Let's make sure that we're not. Oh, we are. Look, we're doing that. That doesn't help. So the reason we were doing this was so that it didn't update constantly. We only want it to update when we cross the boundaries. So we need to change this so that we are using our sector ID. So we'll skip that. We'll give it that directly. So we're taking our value in centimeters. So our sector ID is also going to have to be in 100 million centimeters. And that's fine because we'll just store our sector ID. So that simplifies that. Okay. And rather than using that, we will use that so that we're always we're always using the right value. we're getting the value from the horse's mouth, essentially. So that gives us our sector midpoint in centimeters now, definitely. So the offsets are also going to be in centimeters. So yeah, so that just making sure that this math is right. So we're dividing the ship's coordinates by that. Okay, which gives us our sector midpoint. Right. And then we do need to multiply that, except we need to multiply it by the 100,000 because essentially we're calculating that midpoint, but then obviously that also needs to be in centimeters, so it's a point in space, whereas the sector ID doesn't have this bit of it. And if we promote that to a variable, then we can have a unified sector scale. So if we call that sector size, I suppose, in centimeters. And I think we can set units to centimeters on here as well, just so that we are 100% clear on that. And then these values are going to be that multiplied by 0.5, and then that multiplied by -1 to invert it. Okay, and then that's that one, that one, that one, and then that one, that one, that one, that one, that one, and that one. And I didn't do this one before. That one, and minus. Then that one without the minus. Okay. Okay, then the sector ID is the same thing, just without the multiplier. So that's why we were seeing 1 and 0 on our debug text, because what we were actually doing is calculating the sector ID, and we didn't want to do that. We wanted to do that instead. So we'll copy those wholesale. So that one, that one, that one, that one, that one, that one, and the same here. Right. So the math should add up now. Yeah, and then this 1, 2, 3, 1, 2, 3, 1, 2, 3. Although I suppose we'll use our sector size for that. That's why we did it. Just to keep it consistent, so that when we do our offsets, we're offsetting by the correct number of centimeters. Okay. So we're still spawning that one. It's less. Actually, no, it's the inversion of that, isn't it? Okay, and then our cube. See, the sector cube should be practically in the same position as the ship. Because we need them to be on top of each other. Otherwise, we won't be able to basically generate the content for the ship. This calls for more debug. Yeah, so I wasn't doing anything particularly different there, other than converting that to centimeters, which we're now skipping because we're dealing with centimeters directly. So I think what we'll do, yeah, if we'll see what we're calculating there. On yellow. Okay, so that should be the midpoint of the sector that we are in, which should be basically coming out as an integer. So it should be without decimals. So this working sector midpoint should be the same as this. We will do that just to be sure that it is. Make that a slightly different color. Yeah, so the lighter one should be the same value as the darker one, because ultimately our sector offsets, we're taking row 13, which is 0, 0, 0. So we're not offsetting it by anything, because 0 times 100,000 is still 0. Or 100 million rather. 0 times 100 million is 0. So there should be no offset at all. So that should be the same value. And then I guess just as a pure out of interest's sake, let's see what it's calculating as the sector ID. So the sector ID should be very much single digits. Just thinking actually, so single digits in terms of relative to the star. So in actual fact, no, it should be quite a large number, because it's however many 1,000-kilometer cubes there are between the star and Earth where we are. So that should be quite a large number. You can be purple. Right, let's just see what those numbers are saying. Okay, so this is good. Those two matching is what we'd hope to see. Not quite sure why we're there on the x-axis though. Because this ID coordinate should be much bigger than that, because we are not a simple 1,000 kilometers from Sol. Every 1,000 kilometers, that should go up by 1. So that means our coordinate space is wrong somewhere. Obviously the ship position is a much, much larger number than the sector. So let's just have another look at the math. So it's going to be this one that's messing us up. Yeah, so we're taking the position of the ship, which we know is a big number. Make sure it's actually the local coordinates. Let's update that macro to make sure we're not getting ourselves all confused. So that's definitely local coordinates. Yeah, so we're dividing each axis that the ship is on, which is a big number, and for each of those we are dividing it by how big our sector is in centimeters. So that's our 100 million, and then just just to like verify. So 1,000 kilometers is 1, 2, 3. Yeah, so 100 million centimeters. So actually, how many kilometers in 1 AU? Let's use this. Right. So that is 1 AU in kilometers. Okay. So that divided by 100 million is that. So that is how many sectors there are between Earth and the Sun. So that sector ID should equal that. Now if we then times that value by 100 million, we get the original number. What we're doing is we are rounding that number to give us our sector midpoint. So I mean, we're doing that for galaxy coordinates, but to be honest with you, we don't need to do that with local coordinates because we're not dealing with whole light years. So we could potentially keep it as a float. Although that said, if we wanted that to be the middle of the sector, hang on. Yeah, so that would be one sector boundary. Which means that would be the other end of the sector. So the midpoint is basically the middle of that. So starting from Sol then. So those are all of our sectors. So that's our sector size. So that would be plus our sector size. Oh, and make sure we're just using the same cell. Yeah, so that's our sector boundaries. So that plus that times 0.5. That's our sector midpoints for each sector. So that runs from there to there, with that being the middle. So basically we need the same behavior in this. Sorry, I'm so deep in thought with this, I keep not looking at chat. I hope I'm not missing anything. Oh, that doesn't help. I plugged that into the wrong place. Yeah, so by multiplying each one of these by the 100,000, all we're doing, in actual fact, is just coming back with our base value again. So that times that, we're just returning exactly the same value as we had. That's not actually helping us. Ah, sorry, Delta. Eventually, AJ, yes, I need to add a tick box on there. So if you tick the tick box for like basically display on portal, then if that particular ship combination of registry prefix and registry number, if they're not already on the portal, then it will register that ship with those details from that point onwards. So yeah, basically. And conversely to that, if you untick it, it will remove it from the portal. Yeah, I shall add that soonish. Okay, so what we want then is we want to round that number and then add that number halved. No, we don't. We want to do that, add that. No, times that. Right, so that's the beginning of the sector, and then add that times 0.5. Right. And that gives us our sector midpoint. So can we simply do that? Verify on here instead. We do have to add on afterwards. Yeah, so if we are at 0, 0, 0, then the midpoint of that would be the 500,000. Oh, I think I know why I did this now. It's so that the right, yes, of course. So it's because we want the middle to be 0, 0, 0, not 500, 500, 500. So the midpoint is that, except the boundary for each one would be the 50 million. Hang on. Yeah, because that's not the beginning of the sector boundary, that's the middle of the sector. Yeah, so that would be plus that in half. With 0 in the middle. And of course you'd have minus that on the other side. And then the next sector along would be essentially from that to yeah, the 150, which is what I think I actually had, wasn't it? Yeah, that was it. So which means that the midpoint is 100,000. Yeah. Yeah, so we've got the midpoints are the whole numbers, and then each side of the sector is the half, which gives us 0 in the middle. This is the exact problem we had with Sat A and Sat A not being in the middle, so we had to do it this way in order to make Sat A be at 0, 0, 0. So of course within a star system we want the star itself to be at 0, 0, 0. Yeah, so that means that this is correct then, in that we do want to divide it by the sector size. Then we are rounding that. The reason we're rounding it by turning it into a float is because it does half from 0 as a rounding mode, whereas the round node doesn't use half from 0. It uses something else. Does it say what it uses? Yeah, nearest integer. So when you're dealing with minus numbers, it behaves differently, whereas we want it to do half from 0, regardless if it's a minus. So that's why we convert it to a float first, convert it to text, and then back to an integer afterwards. Which means we don't actually need to do that after all that. Let's just check that again then, now that I fixed that wonky pin. Yeah, so this number is too small, which is odd given that we're giving it a giant number to begin with. And then this number here is responding to the fact that this number here is so small. So we're only like 5 lots of the 1,000 kilometers from the star. So the question then is why is our input number so small? Because again, we're taking the local coordinates of the ship. Hang on a minute. Oh no, that is right, yeah. So the only way that this could possibly be behaving the way it is if that isn't the right number of zeros. Mm, 100, 1, 2, 3, 4, 5, 6. Let's copy it from the length converter just to be absolutely sure. 1 kilometer, sorry, 1,000 kilometers is, give me the box. That. Was this a case of too many zeros, I wonder? Kind of. So we're closer to where we want to be. Yeah, still not enough zeros. Make sure we're timesing it by the right number. That's an extra 0 we had there, we didn't have before. was right. 1 extra 0. Let's make a note of that just so that we're absolutely doubly clear. So the only thing I can think of is that the input value is not being expressed in centimeters, which is weird because we're literally getting the local coordinates of the ship, which should already be in centimeters. Let's make sure that we are definitely getting that from there. Yes, we're only ever setting that, so that's okay. So when we're spawning that, we're grabbing that exact value. So these two numbers should have the same number of zeros on them. So obviously there's a lot of zeros there for the ship, and yeah, nowhere near enough zeros on that. I wonder if this is because we're dealing with that negative coordinate space. Yeah, so we're definitely converting it back to centimeters. And that's definitely 100 million. to the spreadsheet. Yeah. Never enough zeros. Because what we should be seeing is that, oh, hang on a minute. So that's sector size in centimeters. Okay, so 1 AU in kilometers is that. Hang on. So we need that times 100,000. Okay, so that's 1 AU in centimeters. And let's just double check the math. 1 kilometer. It's definitely 100,000 centimeters. Yep. So that's all the zeros that we should have. So if we take that and divide it by that, and of course we'll we'll round that. So that's our that's our sector midpoint, and then we multiply that by the number of centimeters, which gives us the same number of zeros, except this time we are at the exact middle of the sector, because we've got literally just a bunch of trailing zeros. So the sector ID, which is this, so that's sector ID, and that's sector midpoint. Yeah, which doesn't make a lot of sense, does it? So the question is, if this math adds up here, all the right number of zeros, with 149 million as our sector ID, then why does that same math not add up on here? Because we're doing the same operation, dividing it by the same value, multiplying it by the same value, which is that. I mean, we can round it. Might as well just round it. No, I don't want a 64-bit integer. There are no decimals on that, so it doesn't matter. So we're definitely multiplying it by the same value that we're dividing it by to begin with. So all we're actually doing is just trimming the last bit of the coordinate space to give us that solid center. Yeah, which comes up with that. Also, why is that minus? So if that's a positive value of 75 whatevers, then that should also be a positive value of 75 whatevers. That shouldn't be negative of that. So we're dealing with positive coordinates. So that divided by that, rounded. It's not less than that. But even if it were, doesn't matter. In fact, that would increase the number because we'd be cutting that in half. So we're dividing by an even smaller number, which means the output number would be bigger. And then we're multiplying it by that. I am absolutely baffled. Sure it's the right macro we're dealing with. So if I were to just as a test, if we break that vector and then we divide that by our sector size, and then we multiply it. Oh, actually no. And then we round, and then we multiply that by that. Okay, and let's just collapse this. We're going to take all of our math that we were doing and really simplify it to this. Now, it might not necessarily be the exact sector that we want, but that's essentially the math that we're doing. So the question now is, does that give us the right number? Yes, it does. Okay, so these numbers are now correct. I'm not quite sure why the ship coordinates are being zeroed out there. But yes, so the sector coordinates are correct there. Now, I'm not quite sure why the math is working there, but not in the macro, because it's the same math. But Don't know. So our sector ID is now correct. That's that 75,000 value that we're looking at. So the next question is this cubes. Actually, it looks like that one's all right. So that cube represents the galactic plane. So that's why it's all wonky. Now, if we grab the helm, when we move the ship, the cube should not move. Yeah, so the cube is basically stuck to the same plane as Earth. Maybe CSI, yeah. It's a weird issue. I mean, how can the same math work differently in and out of a macro? That's something's going on. I'm going to have to rip the macro apart and rebuild it, I think. Yeah, so this is good. So basically the cube is now stationary in space and aligned to the galactic plane. Now obviously that's confusing when you can see it, but you won't be able to see it. It will be invisible normally. And then this cube will be what spawns content. So if we start moving, how fast are we going? So we want, okay, so 75 kilometers a second is fairly quick. So we want to tune our cube size to the speed that we are moving through the cube, essentially. So each one of these, remember, is 10,000 kilometers in size. So I'm thinking they probably need to be bigger, because it's really going to depend on like how fast you're exploring through space. Because if something was in, say, that cube there, you would no longer be able to see it in that cube, because you're only seeing a 3x3x3 grid around you. So I guess it's the case that we need to think about how far away do we want small content to be detectable. Are we talking, do you want to see it on the other side of the planet, or should we be like reasonably in range of it? I suppose the point is it's kind of sublight content that's being spawned, so we can't make the content grids too big. I'm assuming because we're not deleting them, we're just going to make a big old mess of grids as we fly around. Interestingly, just as a point of note, every single one of these cubes is an independent object in the world, no different than any other piece of content we would be spawning. So if we can spawn this many cubes happily and performantly, then there could be just as easily this many asteroids or this many other ships. Because every single one of these cubes is checking its orientation and location in the galactic space 30 times per second. And as you can see, it's still running very smoothly. And that gives us a lot of hope for content spawning, because it means that we can spawn a lot of stuff all at once and have it all properly track its location relative to the ship without going all laggy. It does look a bit weird having a scaffold around Earth. Okay, so what we need to do now, we can get rid of that, it's no longer needed. Yeah, that's confusing as hell, so I'll fix that afterwards. That should be fine because it's working off of this anyway. But we now want to put the full grid on there. So we're no longer just getting the middle one. We want all of them. Okay, and then we should be destroying those actors. Interesting that it's not destroying those actors there. Why is it not destroying them? I wonder if we need to add an event on here for that. Perhaps it needs to come from itself for authority reasons. Yeah, we could turn it into a live breadcrumb trail. Should have got rid of that debug, really. Okay, so this is the actual grid that it spawns. So this is basically anything within this 3x3x3 grid is content that should show up on the short range sensors. So we want to make sure that it doesn't just keep adding cubes, which it is of course doing, adding many cubes. That's actually, considering how many cubes we've just spawned, the fact that that hasn't crashed is actually quite impressive. Right, let's get rid of this debug. Yeah, weird looking to be sure. I wonder why they're not deleting. Wonder how many we can make before it dies. Remember, every single one of these cubes is updating its position at 30 FPS. Definitely feeling the lag now. But the ship interior isn't really doing much in terms of CPU load. Yeah, that has dropped FPS wise, but still, we wouldn't be spawning that many objects around the ship, so it's a good test. Not removing them. See, generally speaking, you'd need authority to destroy an actor, but in single player, everything has authority. So why? Oh, wait. Because we're not destroying that one. Oops, I forgot that, of course, we've got the proxy object as well. So, yes, the thing we can see is the proxy. So we might be destroying the original object, but of course the proxy still stays. Each thing is a pair of objects. Fair point, Max. Yeah, I think. Oops, no, we don't want to go that fast. Yeah. That's better. Right, so our grid is sticking with us as we go. Right. That only took 3 hours. Right, so this is using that, so that's fine. What I want to do now is change our sector size and see if we can kind of find the sweet spot in terms of size. I mean, you're right, as you say, radar can find very, very tiny things. But I guess we're talking from orbit, looking down at the planet, and that's only like 100 kilometers or so. So it's like, how far could it see something in space? If we expose sector size on here and make that exposed on spawn, then when we create that object, I always lose the event graph. Come back. Then we can stick sector size as the variable that we're actually using on there. And we don't need object scale anymore, so that can go away. Okay, so we're actually telling it how big the sector is, just so it knows. And then when we spawn our sector cube, we also have our sector size. So we can set the scale of the mesh. I suppose it's probably best to set the scale here. Oh, fingers are too cold to type. Yeah, if we set relative scale on here, rather than scaling the actor, and we'll just call that again sector size, because there'll be a conversion we have to do here. So right now we're using that, so that is that many zeros. Okay, so it's that divided by 10 million, is it? No. Oops. Of course it'd be 100, wouldn't it? Duh, because there's 100 centimeters in a meter. You can tell my brain's gone now. What's the equivalent of dividing by 100? Uh, 0.001, is it? 0.01. Yeah, there we go. So again, multiplication being quicker than division, we shall multiply that by 0.01. And that should scale the cube to be the same size as the sector. Of course, we need to expose that on spawn so we can pipe that number all the way through. So giving it sector size there. Yeah, then we're telling that the details, and that's just doing location and rotation. It's not bothering with scale, so we don't need to worry about the scale there. Okay, so that's got the scale there, that's got the scale there. So I suppose the last thing we need to update. Oh no, we've done it, that's fine. So just double check that. Yep. And yep. Though, because of our previous issues, let's oh, that should be okay actually. No, that's fine. And we'll just do just a quick debug here, just to make sure that it is it's doing it as we cross the boundary of each cube, not before. Second will do, because we need to make sure that the sector borders are equal to the sector size that we can see visually. Yeah, the objects that we spawn in space, yes, ideally it would be good to be able to bring them on board. In the same way that we generate objects on planetary surfaces, those are going to be procedural assets that get procedurally built at spawn time. So the things that we spawn in space can be equally as procedurally made with a seed value to determine, you know, their size and wherever they are. When you bring that object on board the ship, obviously the thing you see outside is just a proxy for the real object. So there's going to have to be some kind of transition, and I guess we'll do that via the probe. so that the object that the probe collects is despawned and replaced with essentially a copy of it that uses a different class that you can pick up and carry around, and it then becomes a physical object that you can have aboard the ship. But until that point, it's going to only be a proxy that you can see. That's one of those rendering the ship differently from space, and space being the thing that's moving means that things you see in space are not the real things, they're all proxies. Right, so we want to make sure that regen only happens as we pass into the next cube. Oh, perfect. Right on the boundary. Yes, it's all smoke and mirrors. Yeah, great, perfect. So that's good. Yeah, nothing you can see has collisions, which is why you can fly through planets, because the physics simulation is invisible and happening elsewhere, because of like floating point errors and all sorts of other things like that. The ship that you can see right now is static in the world. It's not moving. The entire vessel, including its outer hull, is all static in the world. So these cubes that are moving, the planet, all of that, even the stars, they're all moving whilst the ship is stationary. And because of that, that's why they all have to be proxies. So the actual physical planet, in fact there isn't a physical planet yet, there will be, the physical planet will be the thing that the physical ship can collide with. So the physical planet becomes stationary in space whilst the physical ship is moving, and then obviously it can collide with that physical planet, whereas the proxy moves around and responds to the movements of the ship. So as I'm moving, and more specifically these cubes, the cubes are a lot more solid compared to the planet. So if you look at the planet and the way that the planet is jittering slightly, that is because of floating point errors. And yet these cubes are using the same principle but done in a better way, and you can see that the cubes are not jittering at all. And the reason for that is that the cubes are managing their own position in the galaxy, whereas the planet is a child of a single anchor point that every planet in the system is attached to. So the planets need to be updated to use the same tech that I've put together for these cubes, so that they become just as solid and just as smooth as these cubes are. Because the parent object for these cubes is 1 AU away. So like there's the sun, there's Earth, and the world origin obviously is where the sun is physically. In the static world, it's right there in the middle of the bridge. In the sim world, it's over there. So these cubes are offset from their parent object by 1 AU in centimeters. So as you can imagine, that's a very, very big number. And without 64-bit world coordinates, they'd be jittery as hell. But even 1 AU away, you can see that they are rock solid despite those distances, which is great, because obviously if they weren't, we'd have problems. But yeah. So we're moving at 75 kilometers per second, and the question we're asking ourselves is, if we want to detect an object in space, how far away do we want that object to be? Now we've updated the point at which a planet appears on the short-range sensors to be 4 times its radius. We did say that 3 million kilometers was the range of the short-range sensors. So I guess we want to be able to find stuff like within the bounds of a planet, but not much beyond it. And I guess ideally we'd want things that are in orbit around moons to only be discoverable if you actually fly over to the moon and have a look. So let's go ahead and make this grid bigger, so that we can get a visual idea of how far away things would be. So with all the fiddling we've been doing, we should be able to just literally change this one variable and have the grid size be different across the board. So right now it's 1,000 kilometers. If we were to make that, let's grab our length converter, 100,000 kilometers, I suppose. So that would encompass, well, let's keep it to 10 actually. So 10,000 kilometers would fit Earth, wouldn't it? Hang on, what's Earth radius? Isn't it 6,000 and something? Yeah, 6,371. So basically, 10,000 kilometers would practically fit Earth. It would overflow a little bit, but you know, that's basically Earth-sized. So if we made each grid the same size as Earth, then you've basically got a grid cube either side of the planet where you can detect stuff. I guess that would be twice the radius in terms of where you can detect stuff. So if we update our variable to that, and hopefully the grid size in game updated perfectly the same. Yep, I can see a grid, so yeah, much bigger. Okay, so now our grid basically surrounds Earth. So again, we're moving at 75 kilometers per second. Yeah, I think that's a more reasonable size. Yeah, absolutely. And this is what's fun about game dev, is solving these kinds of problems and, you know, really thinking outside the box, literally the boxes, to try and like come up with a solution for, you know, solving a problem. So obviously the problem we're trying to solve is we want depth of content within the game. You know, one of the issues with space games like this is that whole kind of ocean-wide puddle deep when it comes to, you know, massive procedural galaxy, but it's empty. There's nothing to do. So to solve that problem, we need to make sure that we also have depth of content in local space. So, you know, this is that essentially. So that as you're flying around a planet, this series of cubes is making sure that things are being spawned that are relevant and you know, in keeping with the location you're at. So there's always going to be, you know, something interesting to stumble across. And yes, I apologize for the joke, Delta. I'll see myself out. Let's just speed up a bit. Not that much. Yeah, so in terms of an Earth-sized object, that's kind of how far away you can detect things. So the way it will work is these cubes basically will spawn content in them in the same way that the Galaxy Gen draws the galaxy. So this is exactly how the Galaxy Gen works. It makes a series of cubes, and each cube is 100 light years along each edge, and that is a sector. So all the stars spawn within the cubes. So what we're doing for local content is exactly the same idea, except the cubes are spawning stuff to interact with instead. So like from here, you could have something all the way over there, which would be over 10,000 kilometers away, which I think is kind of decently far enough. Yeah, the initial ship speed on a fresh game will be slower in the future, and then you'll be upgrading it to slightly faster than it is now. This just makes the Earth look small. As Anasi said, it would be interesting to check stability of this in the outer reaches of the system. So if we go and grab Pluto, we'll just grab the furthest object we can, and we shall summon an NPC for this, get them to go there. So as we fly now, we will spawn a lot of cubes as we go. You may have noticed that the ship aligned itself to the galactic plane as we were going. As soon as you enable the autopilot, it will always try and align to sorry, not the galactic plane, the system plane, which is why all the planets are in a line behind us. As we're starting to slow down, the cubes are catching up. Thank you, Zogbucks. Oh yeah, we'll have all manner of different tech for getting the ship around the place. Okay, so we are currently 241 AU away from what is the world origin. So again, that's 241 AU in centimeters, and that's real centimeters in Unreal units, 1:1 scale. So if these cubes are smooth and not dodgy, then basically problem solved. In fact, if I fly down to the planet, you'll see the issue. So on rotation, you'll find that that the planet is shimmering. Ironically, this one's not doing it too badly, but it's more obvious when you've got a lot of tessellation going on. And it only seems to do it on rotation. Lateral movement is jitter free, weirdly. Not quite sure why that is fine with the distances involved. But yes, any kind of rotation has floating point jitter associated with it. But this one actually doesn't seem too bad at all. Yes, exactly that, because our actual physical space where the ship flies around is a 1 light year cube. When you are half a light year from the world origin, you get teleported to the opposing side of the cube, and at that point you're now working towards the world origin. The star of each star system is sat at the world origin. So in terms of floating point accuracy, the worst it will ever be is half a light year in centimeters. So this planet being 241 AU in centimeters and being generally fine is a good thing. It means that Unreal's large world coordinates are doing the job. But the planet is using a different tech to the cubes, and the cubes are a bit more sophisticated, so they should be even more solid than the planet, basically. Oh, yeah. This far out, everything's still solid. All good. Okay, now for the fun part. Can we spawn something in the cubes and have the ship able to see it? We got 20 minutes left, so let's see whether we can inject this into the sensors. So basically, this this blueprint needs to hold on to the list of objects that exist, essentially, in those cubes. So every time we generate a cube like this, we need to replace this with the spawning of the content. So we need to take the vector, which is the midpoint, and that's basically our seed that we're going to use. To be honest, we can do that probably more simply from the sector ID, because it's going to be a much smaller number than this. So we'll spawn our example cube first, and I guess we need a new function for generate sector content, and we can basically steal some of the stuff that we did for the star system one, for the galaxy one rather. So we need to first of all set up our stream vector stream rather. And this is just making sure that each of these sectors has its own unique random stream, and that is set via the sector ID. So each sector ID is globally unique, which means each one of those cubes has its own unique seed, which means the content of this cube is globally unique within a star system, essentially. So we need to define classes of object that can be spawned, and then the chances of those objects spawning based on where that cube is. So is that cube within the Hill radius of a planet, in which case what type of planet, and then we can kind of dig down from there and work out what it is. So things like junk that an alien species may have left behind is probably going to be quite low on the percentage to be spawned, whereas a random rock will be fairly high. And then the further away you are from an object in the system, the less likely things will be spawning. So it's not a zero chance, it will never be a zero chance, but you'll find that things will spawn more readily around gravity wells, which is what you'd expect. You'd expect things to be captured by planets. Yes, the world origin will indeed be the berry center of the system. So as soon as we have multi-star systems, then that entire tree for the system will all have a berry center as a root. So whether or not it's a single star system or not, it will still have a berry center as the root object. So we'll start with a berry center, we'll then decide, is it a binary or is it like a quintuple system, and then we'll build berry centers as we go, so that every object can be a binary if it needs to be. So every planet will be rooted from a berry center, every star will be rooted from a berry center, so that if we need to make a planet a binary, then we can just tree off that berry center that's already there. For planets that don't have a binary partner, the berry center will just be in the middle of the planet, but they will all have one. That's going to be part of the great data overhaul that we need to do at some point. Right, so something we need to get on here. So I'm phasing this out, but we'll use it for now. So we need to bind global event by class, and that's going to be sector location details. sector entered new star system. So basically, every time we enter a star system, we update the sector location details. If it's not a star system, they'll basically be blank. Cast to sector location details. The beauty of the gameplay message subsystem, which we're replacing this with, is that you can just give it a struct as a payload without having to create a payload object and nest or bury the struct in it. You can just do it direct. Actually, let's just promote that to a variable and keep a copy of it. So every time we enter a new star system, all the details for that star system will be held in this variable, which means when we generate our sector content, we will have access to that. So I suppose the first thing we need to do is work out whether or not this particular sector that we're in, which is our working sector midpoint, and we'll just go off the midpoint as opposed to like where the ship is or anything. So if we grab essentially all of our satellite objects, I will include moons at some point, but for now we'll just use the planets just to make it simple. So we want to do a for each loop on all the planets. And then for each one of those, we want to work out where they are in terms of distance to the middle of the sector. And we'll use this to drive our percentage chance of something spawning in that location. Now obviously we'll have any number of objects spawning in that location. In fact, what I might do is increase the grid size. So instead of 3 by 3 by 3, it's maybe like 5 by 5 by 5. So we can make the grid cubes smaller, but render them like further out. Okay. So we will create subsectors in these cubes the same way that we do with the galaxy. So in the galaxy, each 100 light year sector is split into 1 light year subsectors. So there's 1,000,000 1 light year subsectors per sector. So for these content sectors that we're generating, the content cubes, we need subcubes, and that's where things actually get spawned. Now I suppose we could do it that way, or we could just pick random locations within the cube, which I suppose to begin with is probably the easier way of doing it. But it might create things inside planets. So we need to make sure that that we deduct the planet radius from things to make sure that make sure that we don't dump things inside the radius of a planet. I suppose if we make a map, so we'll call this I don't know, planets, I suppose, and that needs to be a map, and that needs to be, I suppose we'll go with, why I typed radius, I want the float. I suppose float because we want distance and radius basically. Which one did I do first? Just, I haven't named them, so yeah, so we'll take the radius and distance second. Physical characteristics. Oh, fine, do it the other way around. Distance first, then radius. Okay, now for every object within that system, we now have a map containing all of our distances and radii. So we can basically get the smallest value from here, and then determine whether or not that is the closest object. And I'm just thinking it might be easier if I make that a struct. I made one called obstacles. So if we make this an array of struct obstacle. Can't remember what fields we got to. And we did do distance. Oh, perfect. Yeah, okay. All right, yeah, we'll do it this way instead. So we'll just borrow that struct. So we've got our distance value and our radius. I guess we'll also store where it is. And then what we can do, is we can sort struct by member name. And the member name is distance ascending. So yeah, so that the closest one will be at the top of the list. So that gives us our closest object in the system. So from that point, all you would need to do is just get the first object in this array, and that's your closest object in the system. So armed with that information, we can then determine whether or not we are within a reasonable distance of that planet. So yeah, so if we go and get that, and break that. For now, we'll just use distance. So from, and of course this is in centimeters, so let's make sure that we allow for centimeters. Where's my length converter? There it is. So what I'll do is I will store and use the hill radius of the object. So when we're I'll make a new struct for this. We'll add hill radius in here, so then we can use that as our distance marker. For now, if each one of those is 10,000, if we say 100,000 centimeters, just as a hard set hill radius. And we'll set that, hang on. Yeah, so that would be 0. And then the planet radius. Yeah, planet radius, that'll be in kilometers, so kilometer to centimeter. Yeah, so from 100,000 kilometers to the radius, it goes from no chance. Actually, we'll do less than no chance. We'll do more than no chance even. Say like 1% chance. So there's a 1% chance of something spawning anyway. Obviously, we'll tweak that. We don't want star systems to be littered with content, but we don't want them to be empty either. But all the way up to, I guess, not a guaranteed spawn. Let's say 90%. So a 90% chance of spawning something right up against a planet, dropping to 1% as you go beyond 100,000 kilometers. And then we can do random ball with weight from stream vector. So there is our weighted random ball. So that's basically like how we decide, are we going to spawn something, essentially. That's basically the first question we're asking of this is, are we going to bother spawning something? And we're determining that by whether or not we are close to a planet. So if we're not going to spawn something, we do nothing. If we are going to spawn something, then we can grab our sector stream again, and then we can do a for loop. And then we can do random int from random integer in range from stream vector, that one. And we'll leave it at 0 as a minimum, just to add a bit more randomness. And let's say up to say 3 items. Obviously, that's 3 items in that cube, and we'll tweak as needed with this. Again, it would be unrealistic for space to be littered with stuff, so things will be fairly sparse, but not completely not there at all. And I guess from that point, this is when we would spawn those objects. So now if we just do debug spam, obviously we would have to remove any existing objects and spawn new ones. And the random spawn also uses the sector stream. So if we take our working sector midpoint Okay, so for each of this loop, we want to basically make a vector, and we'll just do this in text form for now. So format text, spawning cool thing at those coordinates. Okay. Yes, Delta. Now that we're in the bug fixing phase, I'll just keep churning the builds out. I want to get as much bugs fixed as I can on a daily basis. Okay, so we want so random float in range from vector stream. So from our working sector midpoint, actually I'll break that rather than splitting it so I can see what it is. This is going to be plus, and then we will, rather counterintuitively, we will add from minus half of our sector size. So grab our sector size there, multiply that by 0.5 because it's a value we can change anytime we see fit. So the maximum is that plus half of that, yeah. And the minimum is that same value inverted, so multiplied by -1. Then all three of those are the same. So actually what we're doing is we're saying from our middle point in the cube, pick a point that is randomly plus or minus half of the cube size in any direction, and that forms a random point within that cube. So we'll spawn our cool object. Okay, we're just about out of time, but I want to see the cool object. So let's add the cool object as a sphere. Or just as a cube, to be honest, because we've got cubes already that we're using. I've lost my event graph again. I know it's there. Yeah, so what we'll do is we'll take this sector cube thing, and we will spawn one of those in. Remember, it takes care of its own visible representation. Actually, we don't need the debug, to be honest, do we? We can just literally just spawn it in. But what we will do is make that object, I guess, 10% the size of the sector itself. So what we should see is we should see a bunch of smaller cubes inside the big cubes, and those are things of interest that we have spawned around the planet. see stuff. Okay. So you can see that the grids are now spawning things that you could fly over and interact with in some way. So again, the question with this is, of course, how numerous should they be? Is this too many objects? I would say this is too many objects. But we can game this as well, in the sense that like Earth, for example, is littered with satellites. So around a technological civilization like Earth, we can actually spawn loads and loads of satellites at certain altitudes. So we could take like the geostationary altitude and scatter a bunch of satellites around the equator, or just generally around the planet, because once we've got the spawning system, we can like use this to put content in, and because that content is only spawning when you're in the cube, or at least when that cube is around you, it means we can pack that cube with stuff without causing any serious issues, which means a highly advanced city planet could indeed be surrounded by lots of artificial satellites, and the game can just spawn them in based on the type of planet. So when we're doing the procedural races and we're starting to define things like their tech levels and when we go into their like visual style, when we start looking at the style libraries, if we go like, say, this is a steampunk styled civilization, then we would spawn a bunch of steampunk style satellites in orbit using this system. So just to test how the spawn chance works, obviously right now we're close to Earth, so if we were to speed up and move away from Earth, we should see much less stuff spawning in these cubes, because it takes our spawn chance down to 1%. Yeah, there we go. So you can see that now we're beyond Earth, things are not spawning. It's not a 0% chance, but it's just not likely. But see, there we go. Look, we had some stuff spawn there. I guess we've come back within range of Earth. Yes, Dyson spheres. They're relatively simple because I guess a solid Dyson sphere is less likely than a Dyson swarm, but we can use this system for a Dyson swarm. Like, in some ways we've already just built one. So like around Earth right now, I don't know how well it comes up on stream, but all these cubes around Earth could quite easily be a Dyson swarm around a star. And the nice thing about it is, again, they're only spawning when you're in range of them. Obviously right now they're not going away because we're not destroying them again afterwards, but conceptually you can see the value in this, in that is content that is being spawned dynamically by the game. We just need to turn those little cubes into actual interesting things to look at and scan and at some point bring aboard the ship. Okay, so one last thing before I go, because times are ticking. I will make them quite a bit smaller. And let's replace that with an actual cube. Yeah, and then we'll make sure it's the right one. Yeah, and then we'll actually have it set that mesh. So we want the mesh on this one. Again, expose it on spawn. Okay, so just pop that in there. So we're telling it which mesh to use, and then from here, yeah, we're giving it a 1 meter cube, so it should be the same size that we're after. And I guess we'll use the same material. Set material. So LED red. Right, we should have some smaller solid red cubes this time. That's not a cube. Yes, so planet type absolutely can also drive object spawning. Yeah, absolutely. Like a gas giant. Now take Jupiter for example. It's got like a bazillion rocks around it. They're technically moons, but they're so small that they're just asteroids that is captured. So, you know, around gas giants, rather than having to have like 100 moons listed on the sensors, we can have small rocky objects spawning in orbit around the gas giant. That is basically an irregular small rocky moon that could just be like a few meters across. But we can spawn that around the gas giant, and we can also start building in things like what is the orbital plane of the gas giant. And yes, and if there is a ring system, then we can spawn rocks within that ring as well. Proper interactive ones that you can like push around with the ship, which would be quite cool, like nudging rocks about. Spawn active, blah blah blah. Let's make sure we are spawning the right one. Yeah, so spawning sector cube on that one. Don't know why it's suddenly not. Hang on. Oh, object mesh, not proxy mesh. That'll be why I'm using the wrong variable. Right, yeah. Hang on, just trying to get this done. So we'll promote that to a variable. We will call that spawned objects. And we'll make this a global variable. And it needs to be an array. So we'll take our spawned objects. We will add this object to it. And then we'll just have to, like we do here, we will just go through, destroy them, and clear them as we go. So every time actually not every time we do that. Yeah, every time we do this. So before we do this loop, we need to do the same task essentially, so that we're clearing. To be honest, I could just use sector cubes, couldn't I? Because it's the same. It is the same class, so rather than using that one, we could just use that one. Obviously, once we start spawning actual stuff, we'll make that a generic actor class, actor type, and then we can remove those. Right, so we should see objects spawning and then disappearing as we move out of range of them, so that the engine's not being cluttered with objects. You can be sure it will, Illusion. Okay, there we go. Right, so the same objects are spawning in the same place as they were before. Okay. So as we fly away from Earth, the objects that we previously spawned are disappearing, just as we'd want them to. So all of these little red dots, those are points of interest that you could fly over to, scan, and if they're small enough, potentially even bring aboard your ship via a probe. So as we speed up and leave Earth, you'll notice now that we're basically not spawning anything, because we're not in range of a planet. Now there should be still some stuff out here, just not much. So, oh, there's a couple of things. Oh yeah, I'm probably picking up the Earth spawn chance. Yeah, there we go. So the closer we get to Earth, the more things we start to spawn, and obviously that caps out at 3 objects at the moment per cube. And then they die down again. Okay, so the idea again with this is that we want to reward player exploration. So we want to make sure that there are things of interest which will be spawning in star systems that you will not find on a casual fly through. But you might find if you hang around and actually spend a few minutes just checking the local area around a planet, because there might be something there which obviously from here you can't see anything that's on the other side of the planet. You'd have to actually fly over there to be in that cube and have it spawn something. So it encourages and rewards just being a bit nosier when you get to a star system. So if I fly over here, so let's say that object there, you wouldn't have found that object unless you had made the effort to fly from that side of the planet to this side of the planet. And now you can see that there's an object there. So I think it's going to be rewarding in the sense that even though you might not necessarily be the first person to have explored a star system, you could still be the first person to find something in that star system that everyone else missed because they didn't spend the time flying around, actually searching for things of interest. Of course, most of the time, it's probably just going to be rocks and nothing of particular interest, but there will be alien derelicts and just leftover bits of alien tech here and there that will have a chance of spawning, which keeps the search interesting, because that's what we want. We want exploration and searching for stuff to be rewarding. So we need to know that there's at least a chance that you'll find something interesting. And as I said, once we start building knowledge of planets into this tech, then we can spawn satellites in orbit around planets completely procedurally without needing to pre-generate anything, and which means we can have literally thousands and thousands of artificial satellites without overloading anything. And we can even, to be honest, have a smaller grid system which activates when you're flying at sublight for really, really small objects. And the sublight grid will only come into play when you're not at FTL. So as soon as you go to FTL, it will just disable the sublight grid completely. So you'd have to be at sublight flying around to see the teeniest, tiniest things, which again, we can spawn numerously if need be. I guess we'd probably use that for planetary rings. So if you're FTLing above the planetary ring, like these boxes would spawn the larger objects which come up on the sensors. But if you drop down to sublight within the ring, then the system will be spawning lots and lots of tiny things that you can interact with. So yeah, much success, I think. I didn't think we were going to get there with this tonight because it was all messing up for the first few hours, but we got there in the end, as we always tend to do. Yeah, exactly, Kachi. Do a Kessler syndrome example, that'd be quite cool. Yes, Anasi, spaceborne creatures would be part of this. So where we decide on a planet that there will be spaceborne creatures in orbit of it, then that would feed into this system and it would then spawn those objects. I guess I can't understate the importance of this system. This system is what's going to drive the bulk of the content in the game in terms of stuff that you just stumble across dynamically. The big things like alien vessels flying through the galaxy, that's all going to be handled by a completely different system. But this system, these cubes, that's going to be all the little things that pique people's interest as they're flying about. Yes, peaked, I say. Okay, and on that happy note, I shall leave it there, and I shall wish you all a happy weekend, and I shall see you on Sunday for maybe more of this, and maybe something else. But it might be nice to see whether we can actually start having some of this stuff appearing on the sensors, so there's at least something you can target and actually fly over to. Maybe we can just spawn some potatoes, but we'll see. All right, have a good one, everyone, and I shall see you on the next stream. Bye for now.